Hello students. So today I will be starting a fresh topic called uniform circular motion. Now in brief, this is called U.C.M. U.C.M. Now what does this word mean? Uniform, you know, means constant. If all students have come by wearing uniform, means they have got same color shirt, same tie and so on. So here uniform means uniform speed. So if a body is moving with uniform speed, circular means body is traveling in a circle. So if a body is moving along a circular path at constant speed, we say it is moving, it is having U.C.M. motion, uniform circular motion. A similar word we have learnt last time, that we were calling uniform linear motion. Now see the difference. Uniform linear motion. Linear means moving in a straight line. So when it is uniform linear motion, so here uniform means constant velocity. It is moving along a straight line. So it is uniform velocity. So in case velocity of the body remains same, when it is moving in a straight line, we will be calling it as uniform linear motion, and in case body is moving along a circle with constant speed, we will be calling it as U.C.M. Now we have learned that acceleration is produced when velocity changes. So in this case, velocity is not changing. So the motion does not have an acceleration. So we say it is unaccelerated motion. So here the motion is unaccelerated. In this case, speed is remaining constant, but velocity is changing. Velocity at any point is given by drawing a tangent to the radius at that point. This is the radius at this point, this is the tangent here. So here this is the velocity. Here the direction of velocity would be in this way. Here the direction of velocity would be in this manner. So the direction of velocity is changing, so means velocity is changing. If velocity changes, it means the motion is accelerated. So this important difference you should keep in mind, that in U.C.M. is an accelerated motion, whereas uniform linear motion is non-accelerated motion. Okay, then we have also learned that for how does acceleration is produced in a body. Whenever there is an acceleration, means some force is acting on the body. Without force, acceleration cannot be produced. So here, which is that force? So we'll come to it. Now you see, a body is moving in a straight line with constant velocity. So no force is acting because velocity is not changing. Now in case I want to, at this point, if I want to change the direction, I will have to give, suppose I want to move the body down, I will have to give a force down, then only the body will come down. Now I want to move the body further down, I will have to give further force down. So I have to give the force, then only the direction will change. So the body which is moving in a circle means some force is acting on the body, which is changing its direction. Now let us see with how is the force. Now suppose, as we have learned, this is the nucleus, center of the atom where the protons and neutrons, and electron is rotating in this circle. Now as electrons are rotating in the circle, so means some force is acting on the electrons. So which is that force? Nucleus is positive, this is negative, so there is force of attraction towards the center. So electrons are being attracted towards the center from here. At this point, this is the force. At this point, this is the center. So always there is a force towards the center, and electron is moving in a circle. Now, instead of electron, this moon, and this is earth. Moon is rotating around the earth because earth is attracting moon towards the center. So moon is making a circular orbit. So whenever there is a circular orbit, means some force is acting on that body toward the center. So this line toward the center is changing. So the force is also changing. But magnitude of the force remains same. So this force which is acting on the body so that the body will move in a circle is called centripetal force. This force is called centripetal force. So centripetal force is acting on the body so that the body will move in a circular path. The speed of the body is not changing. So because there is no force acting, as I told you, the speed is given by the direction, by the direction of the tangent. So at this point, if we draw the tangent, it is like this. So there is no force acting here. Force is in perpendicular direction. So it is only changing the direction. Electron is moving, so the force is acting so that it is changing the direction. And the speed is not changing because there is no force acting to increase the speed. If I take this point here, so this is the tangent. So there is no force acting along here. There is a force acting in a perpendicular direction. So if you take a stone, this is a stone, you have taken a string and here you are holding it, now you are rotating this string in a horizontal circle or in a vertical circle. So when they are rotating, the tension in the string provides the centripetal force. This tension in the string will provide the centripetal force, and this will rotate in a circular path. So these are the examples and how. So tension in the string is providing centripetal force. Here attractive force between moon and earth, or attractive force between electron and nucleus, provides the centripetal force. So whenever you will find any body moving in a circle, you should come to the conclusion that some centripetal force is acting on the body, so the body is moving in a circle. This is very important for you to understand. Is it all right? Called centrifugal force. Centrifugal force. I had explained you centripetal force. That is the force acting towards the center. Now let us try to understand what is centrifugal force. This is very important. Now you see, this is a, you can say, stone is being rotated in a circle by a thread. So this is the thread, centripetal force. Tension in the thread is providing the necessary centripetal force. If I draw the tangent at this point, I will get the velocity of the body. Now, to a person who is here outside, he is not moving. This person is stationary. So, what he will see, that a stone is rotating in a circle and there is a tension in the thread is providing the necessary centripetal force. Now imagine a person is at center and he is also moving along with the stone. With the same speed, he is also moving in this circle. So to this person, this stone will appear to be stationary, because when this stone travels to this point, this person also travels to this point. So always the stone is in front of him at a distance radius. So he will find that the stone is in rest position. But then he will observe that there is a force acting, there is a string is under tension, so some force is towards the center. So how then how this is in equilibrium. So we assume that a force is acting outward which is same magnitude of centripetal, but it is outward. So it is opposite to centripetal, and that is called centrifugal force. Now this centrifugal force is not a genial force. There is from nowhere some force is being acted on the stone or anything. This is a virtual force, fictitious force. This is not a genuine force. To this person, he assumed that this force is acting, that is why the stone is stationary. So centrifugal force is a virtual force, fictitious force. See, fictitious force or pseudo force or virtual force. It is assumed by an observer moving along with the body to be acting on the body, so that he can explain his observation that body is stationary. So its magnitude is same as centripetal, but direction is opposite. So this is what, okay, so this is centrifugal force. Now, suppose the string is in this position and the string snaps. Then here the velocity was in this direction, tangent. So as soon as the string snaps, the stone will continue to move with the same velocity. Stone would continue to move with the same velocity in the direction of the velocity. Okay, so stone would be here after 1 second, it would be here after 2 seconds, and so on. I have drawn this sketch to further substantiate about centrifugal force. I will explain that centrifugal force is acting on the body in opposite direction of centripetal, so that the observer who is moving also in the circular path at the same circular speed as the stone, he can explain why the stone appears stationary to him. Now suppose the string breaks at this point, when the string was at OA, then the stone will travel tangent, because the velocity is tangent to the radius, so the stone will travel with the tangent to the radius OA, so along this line, as seen by the observer, which is outside, which is stationary. To him, the stone is moving now tangent to the circle at OA. But suppose in 1 second the stone comes from A to A1, then A1 to A2, A2 to A3 after every 1 second. And because the speed of both was same, so this person also comes at this position after 1 second. So to him now the stone appears again in front of him, but at a slightly larger distance. After again 1 second, the stone moves from here to here, but to this person, it will appear as if it has traveled a further longer distance. So to this person, it will appear as if the stone is moving outward. So to that person, it will appear as if the stone is moving outward like this. Because when he moves from here to here, the stone also moves from here to here, and but becomes here at a larger distance. When he moves from here to here, the stone also moves from here, comes back at this position. So the stone always to this person appears as if it is moving radially outward. So means if this is the stone, so what he will say, because this is the force, centrifugal force that is acting on the stone is moving along radially outward. So this further substantiates the centrifugal force concept for the person who is moving along the circular path at the same circular speed of stone. So this is about centrifugal force. Now we will learn about rotational force, rotational speed, rotational motion. Rotational motion comes due to rotational force acting on it. Now, what is first rotational motion? You know that Earth is rotating about its axis. Earth is rotating about its axis. If this is a ball, and suppose this is the axis, and it is moving. So in rotational speed, the various particles are not moving at the same speed. The particle which is further away is moving at a faster speed, but the particle which is on this axis, it doesn't move at all.